Even though I've only been alive for like 23 years, there are three things that I've determined are pretty much laws nowadays. Number one is, even if I did meet Emma Stone, we would never end up in a romantic relationship. Number two is, wood paneling walls look bad all the time. And number three is that science is fun. Not very many people know about it. So we're here to change that. Not the science is fun part, but about the people not knowing very much about it part. Today we're going to be talking about enzymes.
Science and stuff. Enzymes.
So if we're talking about enzymes, the question is, what is an enzyme? Well, an enzyme is a globular protein, something that acts as a catalyst inside biological functions. Well, that's great, but what's a catalyst? A catalyst is something that causes a reaction to happen much faster than it normally would in normal situations, but it also doesn't get used up in the process. For instance, a fun way to think about it is this. An enzyme can be thought of as a boss or something, trying to run a company and get something done on time. Now, a little play on words, enzymes get things done in time. Enzyme, in time. But that's great and all, but what exactly does that do for us? Well, without enzymes, we would not exist. As a matter of fact, most organisms would not exist. The things that happen in a body take a really long time to actually work. However, with an enzyme, reactions happen up to 10 billion times faster. 10 billion times! Probably the best part about enzymes is they don't cause any temperature change when they happen. You know, that makes body functions actually possible. If the temperature increased with every enzymatic process, we'd probably be dead. Okay, that's great and all. We got enzymes, that's cool, right? Ooh, catalyst. The question is, what exactly do they interact with? The substances of which are being interacted with are called substrates. Substrate substances. This is easy. This is freaking 1, 2, 3, eh? Enzymes do not change shape. They remain the same shape all the time. So they interact specifically with certain substrates. Now, an enzyme basically consists of two parts. We have the protein part, which is called the apoenzyme, and then we have the non-protein part called the cofactor or coenzyme, depending on if it's organic or inorganic. A cofactor is non-organic. It could be something like zinc or iron or something like that. Coenzymes, however, are organic. An example of this would be like folic acid, which is pretty useful in helping come up with purines and pyrimidines, which, remember from your biology class, is the stuff that basically makes up DNA. You know, it's got guanine and adenine and stuff like that. It's pretty important. So what's a coenzyme and a cofactor do? It's very simple. It kind of acts like the key or ignition to an apoenzyme. An apoenzyme is inactive by itself, so it needs a cofactor or a coenzyme to work. After the apoenzyme is activated by the cofactor or coenzyme, then it is able to interact with substrates and then cause the reaction to occur. When an apoenzyme and a cofactor come together, that is called a holoenzyme. Okay, so we've got your holoenzyme here. What is the basic step-by-step event that happens? See, what happens is the substrate comes into contact with the enzyme in an area known as the active site. Once the enzyme and the substrate come together, it forms what is called the enzyme-substrate complex. Once the enzyme-substrate complex is formed, the substrate starts to go through changes as molecules start to get rearranged. After its molecules are rearranged, it no longer fits into the active site and is thus released back out into the body or whatever. This thus lets the enzyme, which has not changed, go around and continue to whore itself out for all the other substrates. Okay, so what can affect an enzyme's performance? Well, it's pretty simple. There are two things that really hinder an enzyme's ability to actually work. One of them is temperature. Much like for kids with popsicles, high temperatures are a bad thing. They cause denaturation, which basically means the enzyme loses its shape and becomes unable to interact with substrates. Conversely speaking, if the temperature is too low, the enzyme will not have enough energy in order to make the reaction actually occur. The other thing that can affect an enzyme is pH balance. Changing the concentration of hydrogen ions in a surrounding area will cause the enzyme to again lose shape and be unable to interact with substrates. Substrates aren't the only thing that try to get into the enzyme's active sites. There are competitors out there. These competitors are called inhibitors, since they inhibit the substrate's ability to interact with the enzyme. Now there are, again, two types of inhibitors. There are the alpha dog competitive type, and then there are the quiet and sneaky non-competitive type. The competitive type is very aggressive in that it actually goes into the active site and completely blocks a substrate from binding with the enzyme. The non-competitive inhibitor goes to a different spot on the enzyme called the allosteric site and then binds it there. When the non-competitive inhibitor binds to the allosteric site, that causes the enzyme's shape to change. When an enzyme's shape changes, that reduces its ability to interact with substrates since the active site is now different. This causes the reactions to slow or not happen at all. But this isn't necessarily a bad thing. Matter of fact, the body uses this very effectively. See, what the body does is something called feedback inhibition. Feedback inhibition happens when the substrate and the enzyme interact with one another. After the interaction happens, the substrate breaks down into its products. These end products then go down to a different enzyme and act as non-competitive inhibitors and bind to the allosteric sites of the enzyme, thus changing the shape of the enzyme, causing the substrates to no longer interact. This causes a waterfall effect. If there's no longer any substrates to interact with the enzymes, there are no longer any more end products. If there are no more end products, there is no more allosteric binding, which means there is no more changing of the enzyme's shape. Therefore, the process of the substrate enzyme couldn't happen all over again. Feedback inhibition is just one of the ways the body is able to regulate what's going on inside itself so there's not too much of one certain product. Now you're probably wondering, what's an example of an enzyme? You know, what's something that an average Joe like myself would be able to know about? Well, it's very simple. You guys hear that? What are you doing? What's it look like I'm doing? I'm eating potato chips. Yeah, I see you're eating potato chips, but I'm trying to make a video here. Why are you eating potato chips while I'm making a video? Whoa, 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 man, it's cool. I'm just showing you an example of real-life enzyme activity is all. Alright, technically he is right. See, when you eat something, your mouth starts to produce saliva. Besides being, wet and gross, saliva is very important. You see, saliva contains an enzyme known as amylase. Amylase's main function is to break down starches into basic components such as glucose. So yes, while your teeth are mechanically smashing down the potato chips into something that is easily digestible by the body, your saliva is also hard at work breaking down the components of the potato chips. So, thanks, potato chip guy. Dude, I'm just you sitting at a different angle holding potato chips. Quit talking to yourself. You know, he's right. I'm even chewing the same potato chip I just took a bite out of. Anyway, thanks for watching. I hope you learned a little bit of something about enzymes today. If you have any questions or comments, please leave them down below and I will try to answer them the best I can. And if you have something that you want to learn about, go ahead and say so and I'll try to make a video about it. In the next episode, we'll be talking about allergies, something very dear to my heart since I have a lot of them. Anyway, thanks for watching, guys. Have a good day.